Okay, now you understand a little bit about scope and you understand about test cases. It's time to put all this together. Once again, up to this point, we've been following everything around the designing of a program, correct? From our inputs, our outputs, our assumptions, our logical order, and so on. So our final piece is now that we is to declare our variables and our data types, our scope, and our test cases for our actual problem. Okay, so let's get back to that. So in this case here, we have went ahead and got our pseudocode. Our next job is to identify our variables, okay, our data types, and then what we'll do is identify our scope. So in this case, as we kind of go through this, once again, if we go back to my previous videos, I just kind of said that our input should be the things that we're going to be processing. We're not going to process it. They're not inputs to our process, okay? They may be identified as inputs in the problem, but they're not inputs to our process because we're not doing anything with it. With that said, we'll just focus on number of snowboards and number of snowboards with boots, okay? So that's our inputs, right? Remember, our variables are our inputs, our outputs, and any subtotals. And what I mean by subtotals are anything other variables that we introduce to the process, okay, that's needed to get to the outputs. Okay, so the obvious ones, inputs and outputs, are very obvious. We've identified those very much in the beginning. But once we do our pseudocode, if we realize we need to save something else throughout it, that's that subtotal I'm kind of talking about. That little, I don't know if subtotal is the right term for it, but that's what I call it, the subtotal. But basically, variables, or what do you want to say, totals that are needed to get to the output, something else we need to add to our process. And we actually had one here, correct? So we'll talk about that here in a second. So for our inputs, this is going to be a variable. Obviously, number of snowboards. What kind of, it's going to be a number, correct? Because it says number of snowboards, obviously. The question is it a is it an integer or is it a decimal? Once again, remember that an integer is a whole number. And so if you can only accept whole numbers for an input, such as this, because you can't rent a half a snowboard, I wouldn't think. So with that said, it would be an integer, okay? And so that's what we would have here, okay? Next one, that's going to be an integer. This is going to be an integer, correct? There we go. Next. Let's see, charges for the snowboards. Well, as I mentioned before, I think in previous videos, anything that has to do with currency will always be a decimal. So charges is currency, so thus it would be a decimal. Charges for snowboards with boots, exact same thing. And our rental total would be a decimal also. Makes sense? Okay. Daily total number of snowboards. These are the actual total number of snowboards that we actually rented. It's not a currency. We're actually trying to look at a total of snowboards that we took out of inventory, right? Well, I should follow the same reasoning behind our inputs here because it's whole numbers. We don't rent a half a snowboard, so that would be an integer. This would be an integer. And our daily total charges, once again, currency, correct? So hopefully this is becoming a little bit easier for you to understand. Our average charge per customer, that's currency again, so we'll make that into a decimal. Not, you're going to have other types of numbers that aren't currency that will still be decimals. The question you got to ask is, can it be fractionalized? Can you break it down versus whole numbers? And if the answer is yes, or possibly yes, you always make it a decimal. If the answer is no, and it's always going to be no, you make it an integer. Okay? All right, so we sit back and we have this now. We identified our variables. So we got one more variable here that we need to look at. And that, as we go through here, you see that we actually introduced the whole concept of customer count. So customer count, once again, we don't rent to a half a customer, we rent to a whole customer. That will be an integer also, okay? Take that out for 1 second, all right? That would be an integer also. Got it? Our next step then is the whole concept around scope. All right, so if you listen to the video on scope, we have two different types of scope. One is local and one is class. And once again, the purpose of scope is to maximize our resources on our computer, not utilize resources when they're not needed, okay? And when we're finished with something, we get rid of it, right? Something like your mom always said, put your toys away or whatever. I don't know if that relates or not, but nonetheless, you get the idea. And so the whole idea here is to do that. So what we want to do is analyze each one of these, okay? And we can analyze them in regards to our pseudocode to actually determine what type of scope it would be. Meaning, if after we run through all the pseudocode, do we need that content anymore? Do we need that variable and its content anymore for the next time through? And if the answer is no, it's local. If the answer is yes, it's class. That's all it is, okay? I'm going to say it one more time. After we run through our pseudocode, or after we run through this process, if after it's finished, do we need that content anymore? Okay. Some people might say, well, yeah, I think you got to display it. Well, let's pretend it's already displayed. Okay. As a matter of fact, let me be specific here. Display all outputs. Okay. So after we display all our outputs, do we need it anymore? After we just put it back on there, do we need it for any reason? If the answer is no, it's local. And if the answer is yes, meaning we need it for the next time we go through it, it would be class. All right, so let's go back and analyze this, and don't make it any harder than that. So number of snowboards, my input. Once I do all my calculations for my customer, I don't need that anymore. Remember, we're adding those totals right here. So that's already being accumulated, so I don't need to keep them past that after displaying the outputs. So that would be local. Same thing here. Okay, and now we come down to charges for snowboards. This is per customer. So after I display those charges, do I need to keep them any longer after I already showed it to them? And the answer would be no. After I show it to them, I'm done with them. Okay, and remember, I've already added those charges to my daily total charges in my algorithm. So I don't need to keep it any longer. So thus, that would be local. Charges for snowboards with boots, same type thing. This would be local. Rental total, since this is all around the customer, local. Now things get a little interesting. Daily total number of snowboards. If you go down and we look at our, I'm sorry, I would look at our pseudocode. I had a brain freeze there for a second. We would look at it. We have to take what was there before and add to it. So we have to take what was there before. So that means we need to keep it every time we go through the process. Does that make sense? If I have to take what was there before, if I deleted it or cleared out the contents, it would always be 0 and it would not work. So in this case, we need to take what was there before, okay? When we get to the physical part of this, meaning the actual program, I'll show you the difference between the two and how it would actually work, or how it wouldn't work in some instances. But in this case, because we need to have it there because we want to look at what was there before, we would make that class. And the same thing here, and the daily total charges here, because we're accumulating those. The average charge per customer, we actually calculate each and every time. We don't accumulate, right? We just calculate it each and every time. So and once we're done with calculation for this time, and after we display it, we don't need it anymore. So thus, once again, that would be local. And our final one down here, the one we introduced that wasn't an input and an output, okay? We're accumulating again. See how we're accumulating? That customer count, every time it goes through, we add one to the customer, we add one to the customer, thus that will be class. All right? So my final list would look like this. Oh, yeah, that'd be class. We got it there. Okay, we have everything correct. And then here is my list. Integer, integer, decimal, decimal, decimal. Looks like I spelled decimal wrong right there. And all the way down. And then you see our scope from local, class, 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 local. That's a good thing to know. Again, before you dive into your program, you figured all this out already, right? And then all you got to do, if you recall from the scope introduction video, that it's all based upon where you declare the variables. We'll know local scope belongs in the procedure, and we'll know class level scope belongs outside the procedure. And that's how it works, okay? And then we'll be maximizing our resources. Does that make sense? Okay. Our final piece here then is the test case, correct? We want to test this and make sure it actually works. All right, so how do we do this? Once again, we need to identify all our paths. As I showed you in the test case video, in this case, these early programs, there's only one path, top down. It goes straight through, okay? There's no if conditions taking it to different paths. We'll get to that here in a couple weeks, but right now it's just one path through. So what we will do is we'll create a test case, okay? This one's actually an interesting one. We might want to create a couple test cases just to make sure things are accumulating correctly. And so, but in this case, there's really still just one path. And what we'll do is we'll sit back, we'll have snowboards, our inputs, equal to, so this is what you do. You just make up I don't know why I'm getting underlines here, but that's okay. You just make up a input data. You can make up anything you want to, okay? And fixing this right here. Not sure why I decided to underline itself. Okay, and then you basically come up with the expected results. You do this in your head, okay? And you sit back and you say, okay, let's make this a little bit easier. It said 3, we'll just do 2. So we have a test case that a customer comes in and rents 2 snowboards and 2 snowboards with boots, all right? My charges for the snowboards will be 2 times 20. So my charges for snowboards, here we go, equals 2 times 20, which should be $40. These are my expected results, okay? My charges for the snowboards with boots, okay? So charges, snowboards, boots equals, and I think that was $30 times 2, so that should be 60. My rental total for that particular customer, my rental total for that customer should be $100. I'm doing this in my head. I'm not even looking at my pseudocode. I'm not looking at my logic. I'm not looking at anything. I'm just determining what it would be if a customer walked in and I knew this. I knew this process already. Does that make sense? So I'm running 2 snowboards. I know they're supposed to be $20 each per the problem. So 2 times 20 equals $40. I'm running 2 snowboards with boots. The snowboards with boots are supposed to be $30 each. So 2 times 30 is $60. My rental total for this particular customer is $100. Do you agree? Okay. If I look at it, my daily total, let's see, I'm going to say daily total for lack of typing here of snowboards. Okay. Sorry about that. Hopefully you understand. I'm doing this one right here. Okay. Should be 2 after it goes through the process. It was 0 to start out with. It'd be 2 now. That's the total we've done. So my daily total is snowboards with boots. It should be 2 also. My daily total charges, I'll just do it this way, DTC. You guys should never abbreviate like I'm doing here. Spell it all out, okay, so I understand what you're doing. I'm just doing this for sake of speed in the video and so on, okay? So my daily total charges should be $100 to it, so that would be 100. And my customer count, okay, my customer count should equal, see, this is why, equal 1 because I mistype all the time. Should equal 1 because it's the first time through, the first customer of the day. My average charge is going to be 100 divided by 1, so that would actually be 100. This is the test case. What I would do is I would go up and walk through and make sure that my logic works. So snowboards 2 times 20, yep, okay, 40. Snowboards 2 times 30, yep. I add those 2 together, give me 100, yep. My daily total number of snowboards plus snowboards, well, this was 0 because we didn't have any before, right? First time through, plus snowboards is 2, so this should be 2. That would be 2. My daily total charges, that would be 0 first time through, plus rental total, okay? And that would be a 100. My customer count is 0 initially, and then I add 1 to it, customer count, and I take that, yep, that all looks good. As I stated before, I think online or via videos, but if not, I'm going to say it once again. Sometimes it's really cool to take this that test case and give it to a friend of yours or an acquaintance or a partner or a parent or whatever and say, you try it. Do exactly what I tell you to do here and see what output you get. You may be surprised if they get it right or they get it wrong, or how they interpreted your actual pseudocode. But it's always a good thing. Sometimes when we write it ourselves, we're kind of very much tied to it. We know what we meant. But the computer doesn't know what we mean. And sometimes it's good to have somebody outside of the computer, in this case, for this logic like this, to actually run it through. These directions should be perfect directions that you could give to anybody and they would be able to get it right. Because what we're going to do is take these directions and, make code out of it, right? And it should be a one-to-one correlation. So make sure you're completing this and make sure whoever, when you walk through it, you understand it and maybe somebody else understands it. Okay? So there you go. Test case 2. If I sat back and I did this again, I'm going to make this a little bit easier. And I'd say another customer walks in and wants the exact same thing. Okay? Wants the exact same thing. And so in that case, we sit back and all this would be the same. However, this would go up to 4. This would go up to 4. This would go up to 200, right? I would be my second customer of the day. And this. So this might be a good idea. What my average should still be 100, correct? 2 divided by 200. Might be a good idea since we're accumulating to make sure these totals accumulate. All right. So I took the exact same test case, which is perfectly fine. I did it again. So we'll just pretend, I walked in, I needed 4 things, and then you walked in and you needed 4 snowboards, or snowboards with both combination of the exact same order. You walk in and say, hey, whatever that guy just got, I want the exact same thing. And that's what we have here. So what should the totals be? And so this case, it allows you to test that accumulation part of it, right? And make sure you're accumulating. And in this case, I can guarantee you our logic is actually pretty good. Okay? What are we going to do with these test cases? Well, what we'll do with them is once we get to writing our code. So right now, let me back up for 1 second. What we know right now is that our logic works. This logic works, okay? By going through our design mechanism here, we sat back and we know what our inputs are, what our outputs are. We eliminated all assumptions. We have determined and we have solved for every output in logical order, correct? We have then went through and determined all our variables, our inputs, our outputs, and any kind of additional totals that we add to our process. All right, we determine our scope based upon if we need it once the process is complete or not. Do we need to keep it for the next time through? And we determine our scope, local and class, correct? We've actually then created test cases and actually walked through my logic to determine that it works based upon my expected results. These are called expected results because we determine these, right? Can we make a mistake on expected results? Of course we can. We're all human beings. But hopefully we'll get it right. Maybe sometimes you walk through your logic and realize your expected result was wrong. This is a great time to catch it. So we have our program now completely designed. I know students hate doing this part of it. I did too. Okay, I'm with you. I hated it until I realized it was saving me hours and hours of time and frustration. By doing this and doing this alone and just focusing on the problem and not focusing on the programming, just focusing on solving the problem. Remember, software development is 2 pieces. 1, solving the problem. 2, programming the solution. Those are 2 distinct different things, okay? Don't try to make it into one, all right? Those who follow my advice do very well in this course and do very well in the curriculum. Those who don't struggle. I promise you this, okay? I 100% promise you this. This is the key, all right? So what are we going to do when we write our program? We'll write our program and we'll come back and we'll use this test case and we'll make sure everything is working correctly. If it's not, we know we have a problem with our program because our logic's wrong, correct? I'm sorry. We say it again. We know we have a problem with our program because our logic is correct. We just tested it. Get the idea? All right. So our next video, we'll program it.